So this is week 6, day 1, and we are looking at adding fractions again. So 2/3 and 1/9. Remember we said that if the denominator was the same, we could add them together. Now the denominator isn't the same, but there's a relationship between the two denominators. So we're looking at 2/3 add 1/9. 2/3 add 1/9. So I'm going to get my whole. There's my whole. And I'm going to split it into 3 equal parts because that represents my 3/3 that make my 1 whole. And I'm going to get another whole and I'm going to split that into 9 equal parts. So you can see how my 9ths are related to my thirds. You should be able to see 3 of my 1/9 is the same as 1 1/3. So 6 of my 1/9 is the same as 2 1/3. Okay, so if I've got 2 1/3, I know I've got this many ninths, 1/9, 2/9, 3/9, 4/9, 5/9, 6/9. If I add, so bring that down, turn these into ninths, on the move. Okay, that therefore is 6/9, and then I can add my 1/9, and I'm going to get, ding, 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 7/9. 7 1/9. Okay, that's it using the concrete resources. Okay, now how can I turn 2/3 into 9ths without using concrete resources? What can I do? Well, I know that I need to do something to my denominator to begin with to turn it into 9ths. So I think, right, what's the relationship? What have I just done? Well, essentially, I've just multiplied them by 3, haven't I? Because 3 times 3, that gives me 9. But I need to actually, whatever I do to my denominator, I also need to do my numerator because I need to keep the value of that fraction the same. If I don't also multiply this by 3, I would actually have 2/9, which is a whole different fraction. It's a whole different amount. But if I multiply my 2 by 3, I'll get 6/9, which we could see, bring this back in so you can see it, is the same, 6/9 is the same as my 2/3. Okay, so there's the proof. There's the proof that whatever you do to the denominator, you also do to the numerator. Okay, so we're going to see if we can bridge moving away from using this to using the abstract method. But remember, you've always got drawn methods to use should you need them. And then because this is already 1/9, we can add them together, and that's how you get your 7 1/9 in the abstract written method. Okay, remember, you can go back through these videos, you can press pause, you can rewind it, you can have another look at it. Okay, so which is greater? Here we go, another which is greater. Which is greater? And we've got some lovely improper fractions. 12 quarters or 12 1/5. Okay, so straight away, some of you might be able to spot which is greater because you'll think, oh, I know, the whole is split into more parts with our fifths than it is with our quarters, and we've got the same amount of them. So we know that the value of this is going to be smaller, so the value of this is going to be greater. But if you don't spot that straight away, do not fear, do not panic. You can turn this into a mixed number or into a regular number if it goes in equally by actually drawing out your quarters. Okay, so you can draw yourself a whole and you can split it into quarters, and you know you've got 4 quarters there. Draw yourself another hole and you know you've got 8 quarters. Draw yourself another hole and you know you've got 12 quarters. So altogether you've got 3. So the value of this is 3. Okay, and then you can draw out your fifths and see how many holes you can make with your 12 fifths. So there's a hole, and we need to split into 5 equal parts. Don't panic if they're not equal. This is why we use pencils a lot when we're drawing, you see, and rulers. There's fifths, 1/5, 2/5, 3/5, 4/5, 5/5, which is the same as 1 whole, absolutely. Then let's draw that again, because we've still got some 1/5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1/5, which is the same as 2. Right, and I can't make another whole group of 5, so I know therefore I've got my extra 2 1/5. So altogether, I've got 2 2/5. So that's 2 2/5. So therefore, 12 quarters is greater than 12 fifths. Lovely. Okay. Let's have a little look at the next question. 6/10 equals so many 30ths. Now again, before we do anything, look at the fractions. Look at what information you're given. Can you spot a relationship? Can you spot a relationship? Okay, so difference between 10 and 30 is 20. So you might think, all right, well, actually, I'll add 20 to this. Oh, and then I can add, because I remember Mrs. Walker saying that whatever I do with my denominator, I've got to do with my numerator. So that would be 26. Does that look right? Because that equals sign tells me that the value of this has to be the same as the value of this. And I don't think that looks right. It doesn't look right. So let's have another look. What other relationship can we spot between 10 and 30? Now remember, we said we had to keep the value of these fractions the same. So we did something with our thirds and our ninths in our first question. Can you remember what we did? Yeah, we did. We multiplied it. We multiplied it because we were splitting it. So we can think, have a little look. 10 times what gives you 30? 10 times 3 gives you 30. So remember, we have to also multiply our numerator by 3 as well. And 6 times 3 gives us 18. Okay, so 6/10 is the same as 18 30ths. Is the same as 18 30ths. Okay, we can have a look at it in a drawn out method. I'll have to do it quite large though. So 6/10. Okay, let's split this into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to shade in 6 of them really lightly. 1, 2, 3, 4, 5, 6. Now I need to multiply it by 3. So I'm going to do it this way. 1, oh, these are titchy tiny parts. I hope you can see them. 2, 3. Okay, we should be able to count 18 parts shaded now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 30ths. Spot on. Lovely. Okay, like I said, if you need to go back through it and you want to use manipulatives, you want to draw it out, pause the video, go through it with me quite slowly and see how you get on, okay?